being a good scientist, you have to ask the right question to get the right answer. How much protein should we be eating per day?
I don't think the data really supports going above 1.8 grams per kg.
Why do we not see people who take leucine supplements or branched amino acid supplements get more muscular?
It triggers mTOR, but as soon as you do that, then you need every one of all 20 amino acids to actually build a protein.
This may be something where we disagree. What's up, guys? Welcome back to the Dr. Layne Norton podcast. I'm your host, Layne Norton, and today we have our first interview guest, and it is none other than my PhD advisor, Dr. Don Layman. Dr. Layman, as I say in this podcast, it is still difficult for me to call him Don 15 years later. Dr. Layman was a huge influence in not only my academic career, but my career overall, helped shape my thinking as a scientist. As you're going to see in this episode, we don't agree on everything. In fact, we do disagree on some things. But what has always been there with Don is the space for a curiosity and asking questions and being open to answers that were different than what we might have thought was going to happen in our research studies. I have never met anyone, honestly, who understood the deep biochemistry of nutrition, but also how it impacted things on a very holistic level and could be applied very holistically. And he had and has such a knack for explaining complex topics very simply without losing the nuance of things. But if you take him into a topic, he can go very, very deep on it. And you're going to see that in this episode. And that is something I feel like I was able to adapt. And I'll never forget when I was going to give my exit seminar for my PhD thesis, I asked him, I said, there's going to be professors in the audience. There's going to be my mom in the audience. Who do I write this talk for? And he said, I should learn something and your mom should learn something. And I've always tried to keep that in mind. And the other thing he was very good about doing was whenever we were giving talks, he said, you should be able to give at least one practical takeaway from whatever topic you're doing this talk on. And so no matter if it was a talk about mTOR and leucine and signaling and initiation factors, I was going to give something practical to take away for people. And that has carried over into my research review reps, which is called Reps for Research Explained with Practical Summaries, because talking about signaling and biochemical pathways, it doesn't change anyone's life. But being able to give practical recommendations does. And again, he was such a master at that. And I am excited for you guys to sit down for a masterclass on protein metabolism. I think you guys are going to love it. So here is my interview with my PhD advisor and the man who shaped much of my thinking, Dr. Donald Layman. Hey guys, I am super excited to have my first guest on the podcast. And of course, for my first guest, I had to get my PhD advisor, the man, the myth, the legend, Dr. Don Layman. And can I just say, it is still weird to call you Don, but thanks for joining us. I'm really excited for this.
Well, it's fun to be on your first one, and I think we'll have a good time, as we always do, discussing things.
Absolutely. I always tell people, I think the most I learned in my entire graduate school experience was simply sitting around a table at lab meetings, throwing out ideas, and then everybody poking holes in it, and then reading studies, discussing studies, poking holes in those. I just learned so much through that process.
Yeah, I think that what people miss is really how to understand studies. I think a lot of people get trapped in the idea they read abstracts and walk away with it. And I hope one of the things I taught you guys is if you don't go read the methods, you don't really know what they were capable of actually studying. And I'd say 50% of the studies out there actually aren't capable of getting to the conclusions they actually designed.
That is such a good point. I tell this all the time to people that being a good scientist, first off, you have to ask the right question to get the right answer. And then you have to design the study in a way to get the answer that not the answer that you want, but to answer the question that you have. And there's so many studies out there, like you said, that pose a research question and then are not designed in such a way to actually answer that question.
Yeah. I think even the worst case is there's a lot of studies now that are showing up, particularly in the nutrition arena, that show there's no difference between two scenarios. And I've always said that designing a study to show no difference is absolutely easy. I could do that anytime I want. The issue is finding a null hypothesis you can actually prove. And there are just so many that say, well, we didn't find a difference. Well, of course you didn't. You didn't design a study that would ever show a difference.
Absolutely. Appropriate control groups. I see that all the time, that the control groups are not adequately designed. They're just kind of an afterthought. Time period to test. You have to, for example, if you're testing HbA1c in a 2-week experiment, well, good luck seeing differences. Like, you're not going to see any difference. Yeah. And so there's just
failure to find is not proof of evidence.
Right. Exactly. And that's, again, we talked about how before this episode, we were saying how, changing your mind is something that happens slowly with the preponderance of evidence over time. And it is a slow shift. It's not like a massive, this one study comes out and we're changing the way we think about everything, but it's a slow shift based on the evidence, because you've got to be careful, because if you're just going to change your mind based on one study, and I think you brought up something earlier, which is if you're only reading the abstract, people don't realize the conclusion is just the author's opinion. I have read so many studies where I go, and you were the person who taught me this, read the results first, read the methods next, then read the discussion, and then maybe go back and read the introduction. But there's so many times I've read results and walked away going, but your study didn't show what it said it showed.
Yeah.
So with that being said, I think my background and your background were something that not unique, but I feel like the way we got into this actually really did us a service compared to the way a lot of people get into nutrition. So can you give us a background a little bit, just briefly, of how you got into nutrition, what your undergraduate was in, how you got into studying this stuff?
Yeah, well, I certainly got into it kind of the back door. It wasn't an intention. I knew that I liked science, so I went to Illinois State University, which is sort of close to where I lived, to study chemistry. And I learned pretty quickly that my skill set wasn't in things like inorganic chemistry and PChem and things like that, but that I had sort of a unique insight into biochemistry. And I was lucky enough to team up with an individual by the name of Arlen Richardson, who was studying issues of protein synthesis, regulation, and aging. And I just had an insight. I had a knowledge about it. And Arlen basically said, hey, you really have a skill set here that's unusual. I think you should get a PhD. And I thought, oh, that's interesting. And he basically hooked me up with Pat Swan and Lavelle Henderson and Vince Haggerty at Minnesota, who were studying muscle biology and protein turnover and vitamin biochemistry, and basically set me up with an internship and all of that. And he said, oh, by the way, they're in nutrition. I thought, okay. And so, I went off to Minnesota basically to study protein synthesis, protein turnover, ended up working in skeletal muscle and getting into sort of nutrition, but it wasn't any grandiose plan on my part. And it really was a case of sort of following the angels. When the doors opened in front of me, was I bold enough to say, okay, I'll do it.
That actually rings very, very true. I tell people I went to do a PhD because I wanted to work in the fitness industry, but this is circa 2003. And at the time, your options were kind of open a gym, start a supplement line, be a personal trainer, go try to be Mr. Olympia. And those, I didn't think any of those were going to be my path. And so I went to graduate school to delay the real world. In fact, I can very distinctly remember asking you, well, what's the difference between a PhD and a master's? And you saying, well, do you want to work in the lab or do you want to run the lab? And I remember thinking, well, I don't know if I want to do either of those two things, but if I'm going to do it, I want to run it, and that's how I got to a PhD. So very much in the same vein, there wasn't really a plan. I just kind of kept pressing on these things that I was interested in, and it led me down a road that, quite frankly, ended up better than I ever could have imagined. And I think, not to jump to the end here, but for young scientists out there, I think we both say it's okay to not know really what you want to do and just be open to things happening.
Yeah. Two other points. Your original question about our unique background, and I think this is a real concern to me, is that you and I got into nutrition by being biochemists. We understood metabolism. We understood basic science, where the majority of people are going into nutrition now are coming out of things like undergrad nutrition, dietetics, or public health, or things. They're not really sophisticated biochemists, metabolism experts. And so what you see is a lot of survey types of things. It's more of a behavioral science as opposed to a biochemical science. And I think people have lost we've lost a lot of depth of thinking in nutrition. And sort of related to that, thinking about your master's versus PhD, I always told students that when you graduate as an undergrad, you really think you're confident you know a lot. When you graduate as a master's, you begin to suspect you don't know anything. And by the time you get a PhD, you're 100% convinced you have no clue.
Yeah, the arc of the Dunning-Kruger, the valley of despair. That was definitely... You will never feel more confident than when you first finish your undergraduate and you've gone through all the textbooks and you go, well, of course, we're just going to test this thing and this is going to happen. And I think after like 3 failed experiments where I got no usable data, did I realize, oh, wow, this is actually much harder than I thought.
Yeah, it's really hard. Pushing back the frontiers of ignorance is actually pretty hard.
Oh, absolutely. And like you said, we both had a background in biochemistry and went to nutrition. And now, having been out of both for a while, I see the pluses and minuses to each. One of the things I tend to see a lot now is I love biochemistry, but biochemists can get very focused on the blades of grass, right?
Yeah.
And they can forget to zoom out and look at the forest. And at the same time, nutritionists can be so looking at the overall forest that they don't understand that the blades of grass do matter sometimes and they need to understand them. And I think one of the things that I really admired about you was you understood what was going on with the blades of grass and could really zoom in, but you also understood how they affected the entire forest when you changed, the soil, for example. And I haven't really come across too many people who were able to do that. It's either a very linear mechanistic thinking, or it's a very, like you said, behavioral-based survey type thinking. And, I felt like our lab, and when I got there, you said this, and I thought you were kind of chest beating, but it turns out you were right. You said we think 5 to 10 years ahead of everybody else. And everybody who went through that lab, no matter their background, they had to understand biochemistry and they had to understand the forest.
Yeah. I appreciate that. And I really, appreciate that you see that. I think it was something it's unique of my skill set is that I'm definitely a big picture guy. I kind of understand a lot about nutrition from agriculture all the way to biochemistry. I see the big picture, but I think what was unique about the people I attracted to the lab, like you or Tracey Anthony or Josh or Suzanne Devkota, they all are great integrators. I think what characterized my lab is that we see the big picture, but we can integrate all the details at the same time. And I think that's kind of a unique skill set. Yeah,
absolutely. And the other thing, when it comes to reading studies, and I'll give you an example that I think you'll kind of get a chuckle with, is if you don't understand, I tell people all the time, scientific studies are big blunt instruments. They're going to tell you what not to do more than they're going to instruct you what to do. And I can remember very clearly, hearing a grad student presenting about, they're in kinesiology and they did some sort of like circuit training, and there was a very specific order to the circuit, and people were getting very hung up on this order. And I said, the student's name was Chad. I said, Chad, why did you have them do the circuit in that order? He said, because it was a 10 by 10 room and it was the only way we could get two people to do the circuit at the same time. So here are these people thinking, oh, there's something specific about this circuit that I have to replicate, when in reality, the scientist is just going, God, how do we get more people through this study in a faster period of time?
I think that's a good lesson to keep in mind, is that there's a lot of things, and we might come back to this point, there's a lot of things in the research literature are there, frankly, because it was convenient for the researcher to do it that way. Exactly. And people end up concluding that, well, that's meaningful, but maybe it's not.
Exactly. Okay, so with that said, I want to ask you some very specific questions. And the first one is the $1 million question. How much protein should we be eating per day? And I'll give you a couple, because I think population matters. So talking about just your average Joe who's worried about their health, probably wants to look good. I don't know anybody who doesn't want to look better, feel better. How much protein should they be targeting and why?
I guess I would frame all of this as the human body has a pretty amazing ability to adapt. And the issues of adaptation relate to some of your choices and not choices, one of which is age and the other is physical activity. Those are two massive things. I think the range goes from a minimum of about 0.8 grams per kg, and we can translate these into pounds if you'd like, up to maybe 3 grams per kg. I think there's a massive range. What do I tell the person you just described? I think they should fall between 1.2 and 1.8 grams per kg. And I usually recommend about right in the middle, 1.5, 1.6, which translates to about 0.75 grams per pound.
Yeah, and you make a good point. I'm sure I have age and physical activity on here as follow-up questions, but just with that range, one of the things that I tell people is when you're looking at protein, you have to understand that the RDA, or the 0.8 grams per kilogram of body weight, is really there to prevent deficiency. Researchers are essentially going, how much nitrogen is going into the system, the person, and then how much is coming out? Fecal matter, urine, sweat, sometimes they measure. And so if you're eating enough protein to have a positive nitrogen balance, I think they threw 2 standard deviations on that and said, okay, that's good. But that doesn't really say a lot about overall health.
Nitrogen balance became the measure in animal science in the late 1800s, before we even knew all of the essential amino acids. We didn't know the essential amino acids until almost World War II. And so it was based on animal science where growth is involved, and nitrogen balance then is a measurable change. And then we translated that into adult health, where nitrogen balance really shouldn't change at all. You're at what we call maintenance or status quo. And so doing a 10-day or even a 7-day measurement of nitrogen balance isn't very meaningful. I always ask people, well, what health outcome can you say that relates to? And the answer is nothing. And so, it's important to recognize it's a very old value. I see nothing wrong with it, as you pointed out, that it's an absolute minimum, but we need to treat it as an absolute minimum because we don't really know how it relates to the health of a 65 or 70-year-old individual. And so it's also important to recognize that those studies are done with 100% animal protein. So basically, they're eating nothing but super high-quality protein, primarily young individuals who still have hormones on their side. And so it represents an absolute minimum, and it basically hasn't changed since 1968 when it first came into play.
Right, and I remember looking at a study a few years ago that looked at people following a vegan plant-based diet at the RDA, finding that they actually were losing nitrogen over the course of several months. And so we're going to come back to that question because this gets into the protein quality. How much does it matter? When does it matter? But I do want to kind of follow up a little bit, because you said that range went all the way up to 3 grams per kilogram, right? So let's say somebody is a bodybuilder, they're looking to build as much muscle as possible. Is that kind of where you're putting that range at, as where there might be their quote unquote upper limit for building muscle?
As far as muscle protein synthesis, I don't think the data really supports going above 1.8 grams per kg. I see a lot of bodybuilders going up to 2.2 range. I see nothing wrong with that, but I think the majority of lean body mass, now we're talking about DEXA measures, that when you go from 1.8 to 2.2 is primarily going to be organ systems and not muscle. I think the difference between muscle gain in an individual at 1.8 or 2.2 is more the resistance exercise they do than it is the protein they take in. So I don't have anything against it. And if you want to make the choice, well, I'd rather have, more protein per day and less carbohydrates per day. I think that's a legitimate choice. But just by going from 1.8 to 2.2, you're not going to have bigger muscles.
Yeah. So I have often thought about this, and this may be something where we disagree. And I think just knowing kind of how sensitive or insensitive these measures of muscle protein synthesis, as well as knowing that we kind of don't really have great ways to measure synthesis and degradation and net balance at the same time, especially if we're talking about like non-steady state kinetics. I've often thought, with no hard data to back it up, but some kind of just intuition, that the dose response of protein is relatively linear up to a point and then becomes very asymptotic, where I don't know if you ever truly cap it out. And there are some studies where, I'm thinking of a study Stu Phillips did a while back where they did, 5, 10, 20, and 40 grams of egg albumin protein. And the conclusion was that 20 grams maxed it out. But if you look at the line, it looks actually fairly linear.
Sure.
And the problem is there's, 5 to 8 people per group, which again, as you know, when you're measuring these things, everybody's got catheters hooked up. Like, these are very invasive studies. It's hard to recruit for. So it's not a criticism of the study, but the absolute difference between 20 and 40 grams was 11%, I believe. And so I've often wondered, is this a hard cap, or is it just something where the returns become so small that you really can't detect them in any reasonable time frame in a research study?
Yeah, and I think that's absolutely fair. It definitely is an asymptotic sort of approach that at whatever 100, let's say 150 grams per day, 160 grams per day, you'll get 85-90% of your maximum output. You go to 200 grams per day, maybe you get 99%. And so, if your goal is to be an Olympic champion or world champion bodybuilder, absolutely. If you're talking about the average person like me trying to stay healthy, what's the calorie trade-off? What's the overall trade-off of going above that? I think it will take perhaps years to detect the difference in actual muscle mass between 1.8 and 2.2. It's not going to be something you're going to pick up in any kind of a study over the next 4 weeks or 10 weeks. It's going to take months and months, if not years, to pick up a difference. We're talking about, sarcopenia type of changes, which are 4% per decade. To pick that up with current methodology, you'd have to control study for 20 years to pick it up.
Absolutely. And we're kind of stuck between, we have relatively sensitive short-term measures of protein synthesis that we are fairly reliable. And then we have longer-term kind of very blunt measurements of lean mass that, as you and I know, are very volatile. And, trying to pick out a half a kilo difference of lean mass over the course of 8 weeks, very, very difficult to do. Your audience and the audience I usually interact with are slightly different in that,
I'm looking at audiences that are below 1 gram per kg, and I'm trying to get them to 1.6 or 1.8. You're talking to people who are already at 1.8. Can they detect a difference at 2.2? And so I think it's a little different. There's absolutely detectable differences between going from, 0.9 grams per kg up to 1.5, 1.6. Basically every study that I've ever looked at shows a difference in those changes. When you go from 1.6 up to 2, now you're talking pretty small differences that we can't typically pick up with the methods we have.
Absolutely. And so that's, again, where I tell people, look at the directionality, and I tell this to coaches. Scientific studies are big, blunt instruments, but coaching is an art form. Yeah. Okay. And you've got to consider the individual. And I agree with you, especially I don't think the average person needs to be targeting 2.5 grams per kilogram of body mass. I just don't think that they're, like you said, going to 1.6, 1.8, you're 80, 90% of the way there. And at some point, the calorie trade-off and lifestyle, trying to get in 2.5 grams per kg is it's easy for me, but I've been doing it for 25 years. It's part of my lifestyle. Yeah. For the average person, waking up and slamming 50 grams of protein is not a normal, situation. Yeah. And so I think, sometimes we can lose the forest through the trees where, hey, if we're getting the average person up to 1.5, 1.6, that's a big win and is more than sufficient for most people out there.
Yeah. We've done, as you know, a lot of studies with lots of people, and from a metabolism standpoint, just a health standpoint, diabetes, obesity, cardiovascular, we find a massive difference in the average person just getting them above 100 grams per day. The average person is around 80 to 90, or even women around 70. And we find that there's a huge metabolic change when you get above 100. So again, you and I have slightly different audiences. For the most part, I'm trying to get people above 100 grams per day. And you start talking with, a 60-year-old female, that's a challenge. That's a serious challenge for protecting muscle. So anyway, just different audiences, different purposes.
So on that note, the next question that's very natural to go to is, how much does age matter? Does age matter for protein? Of course, I know the answer to this, but for our audience, how much does age play a role in protein, and why does it play a role?
Yeah, I think everybody always thinks of protein. They think of growing children, and there's no question that children need protein to grow, but growth is a really pretty small net protein gain. It's probably less than 5 grams per day at the maximum rate of growth. And yet, whether you're 16 or 65, your protein turnover per day is 250 to 300 grams. And so that allows you to continuously repair and replace your body. And the aging thing then begins to come into it. We know that you're basically in more of an anabolic phase up to your mid-30s to 40, where your hormones are basically protecting you. You're getting in a growth and anabolic phase, and then you go into an aging phase. And the question is, what trajectory are you on? And what we've learned in the last 20 or so years is that as you get older, protein synthesis goes down, your ability to do that. Way back when I was in my master's degree and with Arlen Richardson, what we were studying is that as you age, the body does not produce the same number of ribosomes, the polysomes. The protein synthesis goes down. It's not as efficient. And that relates to things like messenger RNA. The structure of messenger RNA changes. The poly A tails get shorter. Everything about it becomes less efficient. And there was a massive discovery, some of what we did with mTOR, but also by the Galveston group, that realized that, if you look at the meal response in a 25-year-old to protein, they'll get a pretty big response to 15 grams of protein. But in a 65-year-old, it took twice as much, took 30 grams. And that thinking has evolved into what we call anabolic resistance, is that as you get older, your body becomes more and more resistant, or at least not as efficient with the protein you're taking in. So to get that same level of protein turnover, that repair and replacement response, you need more protein. So now we've got two things going on at the same time. As you get older, your calorie needs are going down by about 100 calories per decade, and yet you actually need more high quality protein. You either need more total protein or you need at least more essential amino acids. So now you have what we call a problem of nutrient density. You have to have more essential amino acids and fewer calories. And I don't think our dietary guidelines instruct people about that. People just say, well, you're older, you don't need as much, and actually you need more.
Yeah, absolutely. And it's so funny. The first paper you're referring to, I think Volpe was the lead researcher. I still remember the title: Anabolic Signaling Deficits Underlie Age-Related Sarcopenia or Muscle Protein Synthesis Deficit, something of that nature. I remember the very first few words. As you know, some of the things really stuck in there for me. And that was published in 2005, right when I got there. And I remember there was a lot of discussion about that paper because it reflected a lot of the things that you thought to be true leading into that. And I think it's important to point out, it doesn't appear to be a difference in the basal level of muscle protein synthesis, correct?
Do you mean the capacity or the baseline?
No, I mean post-absorptive fasted rates of muscle protein synthesis are similar between young and old, but it's the meal response that changes, correct?
Yeah, right. So, what people need to keep in mind is that muscle is an unusual protein sink in the body, that in the middle of the night, your organs have to still be making proteins. And so since the body doesn't have any storage of amino acids, where does it get it? Well, it gets it from skeletal muscle, and particularly myofibrillar proteins. So they're in a negative breakdown during those fasting periods. And then the meal response is when you get a recovery response. And so what's your anabolic response to that meal recovery? Protein synthesis is a very expensive process. And when you kick it on for the muscle, which makes up 40% of your protein in the body or more, basically everything has to be right for that to work. And as we get older, the efficiency of that whole process gets even more problematic.
Absolutely. And I mean, you mentioned it. I want to be clear. When you're older, you can still get the same response, but it requires a disproportionate amount of protein, correct?
Yeah, exactly. And a disproportionate amount of essential amino acids. It appears to be an essential amino acid issue. So it's just not total nitrogen, as the RDA might imply. It's specifically, you need the essential amino acids. So you have to have a higher amount to try and get that same anabolic response. And again, as you pointed out, almost all these measurements are based on the synthesis side of the ledger. We still are pretty naive about, how to regulate protein breakdown. But I think there's enough data to suggest that the net nitrogen balance, the net muscle health relates to the, changing protein needs.
And I love that you brought up protein synthesis versus degradation, because there are two sides to this equation. And one of the things I always try to get people to understand, I think a lot of people think metabolism is like light switches, where it's, if you're inhibiting something, you're totally turning it off. Or if you're activating something, you're totally turning it on. And I try to explain, it's more like dimmer switches. And the reality is, even when you're building protein, degradation is still on. In fact, it's probably higher, because you're making more new proteins that might be misfolded and need to be degraded as it's happening. But the rate of synthesis is going to be higher during a building phase, whereas in catabolic, both muscle protein synthesis and degradation probably drop, but degradation is now higher than synthesis. And so you have this interplay between these two things. And what really becomes difficult to disentangle, what you said, you turn over, what did you say, over 300 grams of, muscle protein in a day?
Total protein in the body.
Total protein in the body. But your net deposition maximized is maybe 5 grams per day. And I can recall this from many years ago, probably 15, 20 years ago. I read something that people said, well, you know, they kind of made that point. You only deposit 5 or 10 grams a day maximum. So just eat the RDA and 5 or 10 grams more than that. But you're assuming that any excess is just going to be net deposited. And one of the things, again, I try to help people understand is in order to get those 5 grams deposited, you have to have a disproportionate amount of protein to maximize the synthetic response. Because as you said, synthesis is very energetically expensive. And in order to stimulate that to the fullest degree, you said the conditions have to be right, which in my mind, and you tell me if I'm wrong, you have to have enough essential amino acids and you have to have enough total energy as well.
Yeah, exactly. And you know, we know from the study of mTOR that there's a relationship to hormones, there's a relationship to activity. There's a lot of inputs that the body can bring to bear on that regulation. And so, you know, there's just a lot of factors that determine how efficient you are in that process.
Absolutely. Many people ask me what supplements I take, and that's easy. I take the supplements that I formulate and created for my supplement line, Outwork Nutrition. You see, I started Outwork Nutrition because I was frustrated by the lack of transparency in the supplement industry. So many companies were using proprietary blends to hide the fact that they were drastically underdosing their products. And as a research nutrition scientist, I know what having a proper dosage means when it comes to these ingredients. And I knew that many of these companies were just ripping people off. That's when I decided to create my own line of science-based supplements that were good enough to support my training. As someone who has won 5 national titles and 2 world titles in powerlifting and set 2 world records in powerlifting and trains for 2 to 3 hours a day, I needed supplements that would support my hard, intense training and recovery. All Outwork Nutrition products are based on the latest scientific evidence, and every ingredient is included at the proper clinical dose for maximum effectiveness. We provide links to all the scientific research and ingredients and claims on our website, so you don't have to take our word for it. You can read it for yourself. No proprietary blends, no BS marketing hype, no empty promises. Just science-backed supplements to support your hard work. Click the link in the show notes or head on over to outworknutrition.com and sign up for our email list to get 10% off your first order. For everyone out there, because we've kind of talked about mTOR, ribosomes, try to walk my audience through a very dressed down overview of what is mTOR, what is this pathway, why does it matter for these meal responses, like what are we actually talking about?
Yeah, so this is sort of my favorite area. I'm really a nerd about this. The body regulates protein at 2 major levels, one of which is at the gene level, which we call transcription. And then the other is at the cell, at the cytoplasmic level out in the cell, which we call translational. When we're talking about hormones, testosterone, estrogen, growth, we're talking about gene regulation. And that kind of backs off as you get older. Of the genes that are regulated, we only synthesize about 25% of those mRNAs ever get made into protein. A lot of them just disappear along the way. And so once that mRNA, that message from the gene gets out to the cytoplasm, we can then make a protein out of it. Those messenger RNAs get out there and they then get activated. And there's a lot of what we call initiation factors that stimulate that activation. Last time I looked, there's around 13 of them that basically allow us to put on a ribosome. A ribosome is the unit that actually makes a protein. It's kind of like the little builder. And it goes on to this messenger, which is basically the blueprint. And the ribosome moves along the blueprint and it puts amino acids together to make a protein. If we have a lot of ribosomes on a messenger RNA, we call it a polysome, and we're making lots of protein. So now we can see we can regulate this process at different levels. How many messenger RNAs there are, how many ribosomes on the mRNA, all of those things are regulation. back in the late 1990s, a lot of people were studying this regulation, and most people were using the liver at that time because it was an easy tissue to look at. Mm-hmm. And everybody was looking at initiation factors called EIF2 and 2B. And those two are primary regulators in liver for protein synthesis, and they primarily respond to energy. And so what we knew is that protein synthesis in the liver was heavily related to eating. You know, if you ate food, insulin went up, you stimulated protein synthesis. That didn't seem to work well in muscle. And as we looked at it, one of the things we recognized, and this is when Tracey Anthony and Josh Anthony and Greg Paul were all in my lab, we decided that it couldn't be that 2 system, it had to be a 4 system, EIF4. And what EIF4 does is selectively find certain messenger RNAs to change the capacity. And so that was sort of the breakthrough we made in the late 90s. And what we realized is the regulation of that initiation factor, EIF4, was by a regulatory complex known as mTOR. And what mTOR does is basically tell the system that, oh, we sense a meal, we can turn it on to a higher level. And your comment earlier about it's not an on-off switch, people try to think of mTOR as an on-off switch. What it is an indication of recovery. So during a nighttime when you're fasting, mTOR gets down-regulated in skeletal muscle, but protein synthesis is still going on. The muscle's still making protein at about 1% per day. And when you trigger it after a meal, mTOR will kick on and it turns it up to maybe 1.5 to 2% per day. So 50 to 100% response. So it's not an on-off switch, it's an upregulation. And it's an upregulation due to food. So what we do is that when you're young, mTOR seems to be regulated by hormones, insulin, for its growth factors. And as you get through growth, then it is regulated by the branched-chain amino acid leucine, which simulates mTOR and tells it to. So leucine, we could go into it, is a unique amino acid in that it's not metabolized in the liver. It's only metabolized in peripheral tissues. And so what you have is an amino acid that once you eat, the muscle gets a sense of what you just ate. Did it have enough protein there to kick on this expensive system, turns on mTOR, mTOR then triggers the body to increase the capacity for protein synthesis, and it also targets mRNAs that are specific to myofibrillar proteins. So it's a recovery and targeting process as opposed to an on-off switch, which I don't know if that was way too much into the weeds or not.
No, it's great.
It was fun for me to think about.
Probably, yes. It was funny. I believe you've been on Peter Attia's podcast, and I've been on there several times, and Peter's a friend of mine. And it was funny. On one of those episodes, we started talking about mTOR, mRNA, ribosomes, and people said, wow, I didn't realize you had that, depth of knowledge. And I said, well, yeah, but that, this is stuff for nerds like you and me. This doesn't really change anybody's life, right? Knowing about mTOR.
Yeah.
But I do remember one time I went into your lab and you had a habit of doing this, which I loved and hated, which was you would ask me very prodding questions kind of out of the blue. And I sat down at your desk one day and you said, Lane, why do you think the body evolved to sense leucine out of all the amino acids? And I just went, oh, I'm just trying to get my PhD and get out of here, But you already touched on a lot of it, which is you would want an amino acid that's not really touched by first pass metabolism, the gut and the liver. You would want something that what appears in the bloodstream is reflective of the quantities you eat in the diet, which leucine is. You would want something with passive transport across the cell membrane, which leucine does. It's concentration driven. And you would want something that reflected overall protein quality. And with rare exceptions, corn maybe being one, isolated corn protein, you don't really see high leucine levels in low quality protein sources. And, that's one of the things I loved about being in your lab, also hated, but loved, was that you didn't just want us to understand what was happening. You wanted us to understand why it was happening.
Yeah. And I'm still fascinated by the branched chain amino acid sort of evolutionary issue. And, I think one of the things that's unique about them is they're metabolized as fatty acids, where essentially all the other amino acids are metabolized as glucose. And so those amino acids are metabolized in the liver or the gut because of glucose-oriented tissues, where the branched chain amino acids are metabolized in peripheral tissues, which are more capable of using fatty acids. So, I think that's a fundamental issue. In fact, when the original research with leucine and protein synthesis was being done way back in the mid-'70s by Goldberg and Boos and all of those people, they thought it was an energy issue. All of those research studies believed that it was going to be an energy issue, and they were trying to make it an ATP issue. At that point, they had no clue about mTOR. They didn't really understand initiation factors. And so they were set out to show that it was going to be a fatty acid issue, which they ultimately showed wasn't the case, which kind of left it out there for our group and others to sort of sort out 15 years later.
Yeah. And so on that note, why do we not see people who take leucine supplements or branched chain amino acid supplements get more muscular? Where is the disconnect here? Because I know this has been a hotly debated topic. And I certainly, when I got to graduate school, was actually promoting taking branched chain amino acid supplements, and even had at one point a supplement company that sold a branched chain amino acid product. Now I don't have one. Where is the disconnect there? And why does it seem to help to have high quality proteins that are high in branched chains for muscle building, but just giving supplemental branched chains or supplemental leucine doesn't seem to make a difference?
Well, yeah, the easy answer is the role of leucine, as I just said, is a recovery response. It triggers mTOR to change the capacity for protein synthesis. But as soon as you do that, then you need every one of all 20 amino acids to actually build a protein. And so, turning on the light switch but don't have any electricity behind the switch isn't going to make the light come on. And so you really have to have all of them. And does supplemental make any difference? That's kind of an issue that we were talking about. Is 2.5 grams per kg going to be better than 1.8? Well, once you saturate the system, it probably isn't. And so, I think that, is there a role for supplemental branched chain amino acids? I think there's a few studies, a few that you did, and Doug Patton Jones and some others that showed that, if you have some protein, like 15 grams at a meal, and you add in leucine to make sure there's the equivalent of 3 grams of leucine in the meal, you can get a pretty robust response. Is it the same as having 30 grams of total protein? Probably not, but there's no studies to really compare those. But what we can do is say if you had a small lunch meal, say, for example, you're an elderly female who can't eat a lot of protein, but can get in 15 grams, would there be a role for supplemental branched chain? Maybe. I think that that's a case where it could be useful. Some guy who's eating 250 grams per day, the idea that leucine is going to have an effect on that is silly.
Right, absolutely. And I completely agree with you. I think this leads to the next question I wanted to ask, which if you are at low protein intakes, then we're fortifying with something like leucine, with branched chains. I mean, the studies that you and I did together showed this, that you can take a low quality protein source. If you match the leucine content, like we did this with wheat and whey, we showed very distinctly different responses to wheat and whey. And then we went back because of some reviewer criticisms and added supplemental leucine to the wheat group. And what happened was the responses were completely equivalent, exactly the same when we matched the leucine contents.
Yeah.
So
does that translate into exactly the same muscle mass 10 years from now? We don't know. But in terms of the main regulation of protein synthesis, as you just pointed out, they were exactly the same. So, the initial response, at least to the meal, is very heavily dependent on the leucine amount. But once you trigger the system, then you need the rest of the amino acids, and you can get those from various sources.
Absolutely. So on that note, protein quality, there's a lot of debate out there about protein quality. My PhD right back there was all about protein quality. Plant versus animal. What are the considerations? When does it really matter? Is there a time where it doesn't really matter? What are the considerations people should think about when considering protein quality?
So basically, we talk about dietary protein, and one of the first lessons I learned in graduate school from my advisor, Pat Swan, was that we don't actually have a requirement for protein at all. What we have is a requirement for 9 essential amino acids and then non-specific nitrogen or organic nitrogen, which you might consider to be non-essential amino acids. And so your first need is satisfying that need for the 9 essential amino acids.
Let me stop you real quick. Non-essential versus essential, what's the difference for our people who don't know the difference?
So there are 20 naturally occurring amino acids in our body that are required for making protein. So we have to have all 20. 11 of them we can actually make in the body. So if we have a mixture of amino acids, we could make the alanine, for example, which is a non-essential amino acid. We can make all of that we need. There are 9 that are considered essential or indispensable that we can't make in the body. So we need essentially a daily supply of those. So those are what we call the most limiting in terms of defining proteins. What we know is that the amount of essential amino acids in, say, our human body is around 50% essential amino acids. And if you look at the essential amino acids in animal proteins like milk or eggs or fish or meats, chicken, beef, whatever, it's around 45 to 50%. But if you do the same thing and look in plant proteins, it averages around 35%. Ranges from around 40 in soy down to about 25% in nuts. So the essential amino acids, they're there for a purpose. And in plant proteins, what you have is more of what are non-essential. The plant needs more of those amino acids because of plant structures. Leaves and stems and flowers and roots are different than arms and legs and brains and hearts. And so they're just a different mixture of essential and non-essential amino acids. So that's kind of the basic, is the difference in these non-essential amino acids. Animal proteins always have more of the essential. When does it make a difference? Well, it makes a difference then the lower your protein intake goes. The other aspect of it that we should mention is that in plants, around 50% of the protein is bound to the structure of the plants, to fiber. And so since the human can't digest fiber, those amino acids are called not bioavailable. We can't digest them. So most plant proteins, they have fewer essential amino acids, and those amino acids are only maybe 60% bioavailable. So we've got two things kind of going against you. So the issue is then, how much do you eat? If you eat only about 50 grams of protein per day, you will be deficient in essential amino acid. And a lot of vegans and vegetarians can get that low. The average for most vegans is around 55 per day. If you're above 100, 110, 120 grams per day, probably doesn't really matter much. You're going to have enough total protein that you probably cover it. So, again, what are your goals? What are your age? it's a lot easier for a 20-year-old to be vegetarian because they have all the hormones and everything on their side. They're more physically active than it is for a 65-year-old who has to now have more essential amino acids and fewer calories. So that's just a hard thing to do on a vegetarian diet. And the solution to that then is probably supplements. They can go to isolated proteins and powders and things like that. So there are solutions, but the average American doesn't have the food skills, the food knowledge, or the desire to do that.
Well, correct. And so that's, one of the things when I talk to people who are vegan or plant-based, I'll say you absolutely can build as much muscle doing that as you can with using, more animal proteins, but you're probably going to have to do more leg work. You're going to have to eat more total protein. And I wouldn't say you have to supplement with an isolated plant source of protein like a soy or some of these other ones, or maybe a combination. Combinations can work well. Stu Phillips has some data on that. But it's certainly going to help because you're going to get around the digestibility issue if you're using an isolated source of plant protein. Isolating it takes away that, as you said, much of the protein in these plant proteins and the intact plant proteins is bound up in the fibrous plant material, not accessible to digestive enzymes. Now, typically, if you cook, that can help. It can increase digestibility, but you're probably not, for most plant sources, getting to close to the digestibility you're getting with animal proteins, which are very bioavailable.
Yeah.
So,
I mean, the statement I made earlier was that, if you want me to design an experiment to show no difference, I can always do that. So, you look in the literature and you'll see these headlines again, the abstracts will say, there's no difference between vegan and omnivore diets. And I think, well, let me see the methods. And what you go in and you find is that they're using supplemental proteins, they're using ultra-processed foods, and they're using a lot of soy and legume types of things, none of which Americans want to eat. And they're then doing it at 120 grams per day. Of course, there's no difference. I totally agree. But people will say, well, you should substitute and eat more almonds. Well, if you just take the RDA, you can meet your RDA for protein, 56, 58 grams of protein with 3.5 ounces of chicken breast. It takes 430 almonds to do the same thing. And that's a serious amount of GI distress.
Right. No, I think it's kind of a bang for buck issue. But again, like I will tell people, you can absolutely build muscle on a plant-based diet. You're just going to have to think a little bit more about it. And you're also going to think about, if you are somebody who is plant-based, trying to build muscle or maintain muscle and calorically restricted, you probably are going to do better supplementing with an isolated source of protein, because most plant sources of protein are not single macronutrient. They are either protein and fat, or they're protein and carbohydrate. And again, you're packing more calories in than you would with some of these animal sources, and a higher volume of overall food, which there are pluses and negatives to. If you're talking about an elderly person who maybe not have as much of an appetite, that food volume can be a real problem. If you're talking about somebody trying to lose weight, maybe not as much of a problem. So there's always trade-offs here. And one of the things I really try to impress on people is try to get away from thinking about good and bad and start thinking about trade-offs of what you want. And when it comes to protein needs with plant versus animal, again, in that PhD thesis sitting right back there, we showed, comparing wheat and whey protein, once you got high enough in total protein, there was no difference in the anabolic response. And so again, if you eat enough total, and that's, getting around that 1.6, 1.8 grams per kilogram of body weight, if you're getting up around there, you're probably not going to see differences. And I actually remember a study looking at rice protein versus whey, and the takeaway was there was no difference. And then you go look at the amount they're looking at, and it was 40 grams of each. Well, of course there were no difference. Both of them maxed out the system.
Yeah. Yeah. So, I think that we always have to be careful of what we think as nutritional biochemists as a theoretical diet can you and I create a plant-based diet that meets the essential needs? Absolutely, we can. But then you have to ask, what do people do? What's the evidence out there? And what we know is that in the United States, the average vegetarian intake is around 65 grams per day, so it's lower. The average vegan is around 55 grams per day, so even lower yet. And if you look at plant-based protein in the United States, and this is actually true worldwide, 80% of the plant-based protein consumed in the United States is wheat. So as you and I know, wheat is probably the single worst protein you could ever come up with. It's totally deficient in at least five. I mean, it's limiting in at least 5 amino acids and probably deficient in at least 2.
I would probably make an argument for collagen being the worst, at least for muscle, but wheat would be my next one.
I get that one, but it's an awful protein actually when it stands alone, and so I think we have to be careful when we start making public health recommendations that suggest everybody should be more plant-based. You have to bring into consideration what people actually do. And we've had a plant-based narrative since the 1980s with the food guide pyramid, and we know the diet has gotten progressively worse. We've had 35% decrease in dairy and egg consumption, a 40% decrease in beef consumption since the 1975 range, and there's not a single thing in health that has gotten better. And so what we know is the diet has deteriorated as we've diluted it with these relatively poor grain-based plant proteins.
And I think the other thing to point out here is I'll tell people, because of food technology now, there is a good way to do a plant-based diet. There's a good way to do a low-carb diet, and there are bad ways to do it, right? Sure. And now you have so many ultra-processed, hyper-palatable plant-based foods. If you're eating a whole intact plant-based diet, maybe supplementing with an isolated protein, it's going to be hard to not be getting in quite a bit of fiber and overeating calories. But hey, if you're eating vegan mac and cheese and vegan chicken wings and vegan ultra-processed everything, that's not a high-quality diet. And there's actually research to show where they parse out high-quality plant-based diet versus ultra-processed or low-quality plant-based diet. And they show an inverse response of mortality, cardiovascular disease, cancer, because really, and I think this with some of the plant-based protein stuff, there's a lot of research studies that come out looking at animal protein versus plant protein. There have been some that showed positive benefits to both, especially when you're looking at quality of life in older people. But usually plant-based comes out stronger than animal protein. My problem with that, and it's not so much a problem because it is an inherent property of the food, but my problem with that is it's very much confounded by the fact that with plant protein, you're getting a lot of dietary fiber as well, which has its own independent health benefits. And so my feeling is it might be less about the actual plant protein and more about what you're consuming along with it.
Yeah, I mean, should Americans have a better plant-based diet? Absolutely. Sure, we should all be eating more broccoli and green beans and blueberries, and I 100% agree. But we're currently getting about 30% of our calories from animal-based foods, and we get about 65% of our nutrients from that same group. What we know is that almost 83% of our plant-based calories come from refined grains and added seed oils. There's no evidence that that's healthy. Should we be having better plants? We know that 80 to 90% of Americans are not eating the recommended level of red and green vegetables, of legumes, fruits, etc. So absolutely, we should have more fiber in the diet. And I think you're right that when people make those changes toward a more healthy diet, we see improvements. They like to try and argue that it's a protein effect or an animal effect. It's really just a diet quality. I think people need to step back and think about why does the dietary guidelines describe their food models as the healthy vegetarian diet or the healthy Mediterranean diet. What it means is you can have a very unhealthy vegetarian diet. You can have a very unhealthy Mediterranean diet. Basically, these are stylized to basically aim at what we think is a healthy diet. It's not that there's some absolute some absolute model out there that's proven.
Exactly. And with low carb too, I mean, I was at the store and I saw a ketogenic ice cream that actually had more calories than regular ice cream. And I go, boy, we're really missing the point here. You know what I mean?
Yeah.
Again, if you're doing,
I think the low carb thing, I think that's a huge issue that, how in the world can the dietary guidelines not address the low carb issue? We now have 30 plus years of studying low carb diets, and we know they're highly effective. How come people aren't modeling that? The fact that they're ignoring it under the disguise that, well, it's somewhat controversial. I mean, give me a break. The fat theory is far more controversial. It's been studied for 50 years, and it just gets worse every year.
So, and on that point, like with overall diet quality, one of the things, and I've done a lot of content on this, is there's a lot of push now that's anti-seed oil. And what I've said is, hey, I don't think that necessarily seed oils have something inherent property about them that's negative. But when you're adding a bunch of oil to the diet that's empty calories, you're getting a much more, you're having, I always tell people, based on the food consumption data, not reported data, because we know people underreport by a lot. Based on actual how much food is produced versus how much is left over in waste, the difference of which is what people consume. The average calorie consumption in the United States is 3,500 calories per day. The average physical activity is less than 20 minutes. And so we can argue about some of these things in the margin, but that energy toxicity is such a massive problem. And just fixing that would probably fix 75 to 80% of the problems. I mean, I'm throwing out a number here, but I don't know if you agree or disagree, but.
No, I totally agree that, I'm a big fan of what's, people have talked about has been a dilution of the American diet. The food guide pyramid diluted out the nutrient density with carbs. And, I think that's an issue. And even the seed oil issue, if you look back in the 1950s, and I'm not going to get these numbers quite right, but ballpark, there was about 50 pounds per capita per year, and now it's 80. And the animal fats that it replaced went from about 20 to 5. So we had a net increase of almost 50 while we had a decrease of animal fats by 15. There's your calorie difference. We had a net increase of something like 35 pounds of seed oil per capita per year in the U.S. diet. So, I mentioned earlier that there was, from the beginning of the food guide pyramid, there was a 35% decrease in animal foods. There was a 40% increase in grain products and seed oils. So we more than offset whatever calories we may have saved from the animal products with these ultra processed foods that the food industry wanted to sell. One of the examples, people always look for bias, and I say, well, one of the issues is the food industry that a company selling cereals that can go out and buy a bushel of wheat for $6, make it into 44 boxes of cereal that they sell for $4 a piece. That's a 30-fold profit margin. There's no place else in the food industry where you can see something like that. There's a massive profit incentive for the food companies to sell grains.
Yeah,
and seed oils.
And I think, one of the things to keep in mind too is that protein is the most expensive nutrient to produce. And when we're looking at rearing animals, it's not a question of like, how do we get the best rear possible? It is, what is the lowest cost for us to get this to production? And the lowest cost typically involves feeding the minimal amount of protein to get that animal to grow.
Yeah. And there's no question that protein is the most expensive part of the food system. And so there's no question that the food industry would like to minimize it. It's expensive to produce. It requires refrigeration. It has spoilage. Everything about it makes it pretty much a zero profit margin item in the grocery store, in the food chain. So, I think it's something that we really need to consider how we protect it.
Yeah, absolutely. And so on this note, because this is kind of pulling into this, I wanted to ask you about the carnivore diet. Now, I've done a lot of content on this. In fact, I've debated people in the carnivore community, and I can remember being on my first debate going, my research was funded by the National Dairy Council, the Egg Nutrition Board, and the National Cattlemen's Beef Association. Never in a million years did I think I'd be on a podcast defending the virtues of plants, but here we go. And so I think, on one hand, I do like high quality animal protein, but we have people saying, well, plants are actually toxic. They're trying to kill you. There are these defense chemicals in plants. How worried should we be about that stuff? Where do you fall in this line? I mean, I think it sounds like you do think dietary fiber is a very important component of the diet and probably not something that we should consider toxic.
No. Frankly, I think the fiber recommendations are not well justified. I think the average American's like 12 grams or less. But the idea that something like 14 grams per 1,000 calories, I find that kind of ridiculously high. I think if people were closer to 20 grams per day, I think everything would be better. But I'm not sure I buy quite the focus that I see. Is fiber important? Absolutely. I have a paper in Nature with Suzanne Devkota about fiber and gut microbiome. So, I think it's fine. I'm a fan of the phytochemicals that are in plants. I think anthocyanins and flavonoids and all sorts of plant-based antioxidants are an important part of the diet. So I'm in favor of that. Carnivore, I hear carnivore, I hear keto, I hear vegans, and I say, well, those are the extremes of the spectrum, and I guess that there's room for zealots in our life. So I don't have any particular problem with it. I think it takes a lot of knowledge and dedication to pull that off. I'm not really interested in those extremes. Can they work for people? Yeah, probably fine. Is there going to be any long-term health negatives to it? I think it's been being used long enough now that most people seem to be okay. I think there's some very interesting metabolic aspects of the carnivore that I think are interesting to think about. Some of the blood changes that we see, I think raise the question of whether these are clinical markers that we actually understand or not. We could talk about A1C, for example. Anyway, so I'm not a fan, but I don't go out and say, well, that's the dumbest thing I've ever seen. I think that there are people who have health problems that need extreme diets, and it works for some people. I couldn't do it for 24 hours.
Yeah. I mean, obviously there's a lot of anecdotal reports out there with this, of people saying, well, they tried it and their levels of inflammation went down. And my response is always, well, did you get your CRP measured? And the answer is always no. And I find what tends to be a common thing that I hear is I think a lot of these people have autoimmune or digestive problems where they haven't really done like due diligence on, okay, which one of these plants in particular are causing me issues? Because, you have people with FODMAP sensitivities, you have people with IBS that are very sensitive to certain plant-based foods where they have a greater sensitivity to the pressure from gas that gets produced, a more robust pain response. Yeah. And so I think what happens when you do a carnivore diet, I mean, it's essentially an elimination diet for all intents and purposes. And so,
and I think it's another form of a low carb diet. I think insulin is highly inflammatory, and that a lot of people will benefit from reducing carbs, particularly grains in their diet. So the carnivore is a form of a low carb diet. I think those are all legitimate reasons to try it. And so if I, had some extreme health issue that I thought it might merit, I would give it a try. But again, as a normal normal diet for healthy individuals, I'm never going to recommend it.
Well, one of the things I'll tell people is like, listen, if you do a carnivore diet and you lose 50, 75 pounds and you were obese, you're going to have a hard time convincing me that you're not healthier overall now by doing that.
Absolutely.
Do I think that you'd be as healthy as if you did that while also including a more diverse array of like plants, fruits and vegetables?
Sure.
I don't think you'd be as healthy as if you did that. But again, if that's the only thing that you could be adherent to, then, I think that there's other ways to get to Rome. But again, I'm not going to argue that somebody who does make that big of a change could be healthier overall. My major problem ends up being around the claims about plants being toxic and all this such nonsense,
I don't really buy that. I think that if people ask me, what's the single most important thing in nutrition, I would always start with calories. If you get your calories under control, your chances of being healthy are pretty high. And if you look at a vegetarian vegan diet, they typically control their calories because of the high fiber content. Okay, it's highly satiated. If you look at a keto diet, they typically control their calories because it's not very tolerable. If you look at a carnivore diet, just how many calories can you eat if it's nothing but meat? Most people, it's just hard to do. And so I think, to your point, the first benefit from any of those extreme diets is there are ways to control calories.
Absolutely. And I think the other thing I want to point out to people is you can hack your way around these diets to where they don't control calories. And unfortunately, I think some people can believe that there are inherent properties to a vegan diet or a carnivore diet or whatever diet that, as long as they still are in that diet with the rigid dietary rules, that it won't matter how many calories they consume. And that's just not the case. And again, you can do a ketogenic diet, and if you're eating ketogenic ice cream and dumping butter in your coffee and like you're putting in a lot of calories, it's not going to have the same effect as if you're doing like a minimally processed, whole food ketogenic diet. Because as you pointed out, that sort of diet just isn't that palatable. You're just not going to be that hungry for it. And the same thing with a whole plant-based diet. It's just, they're not foods that are easy to overeat on. And the same thing goes for a whole carnivore diet. So I completely agree with the calorie effect. And I think that I have this theory that a lot of people they don't like the idea of energy balance. And I think it's because the self-responsibility becomes inherent to the equation. And yes, there are conditions that can reduce your energy expenditure, or we do know that obese people, their appetite regulation is not as tightly controlled. They have a greater reward response to food. And so I don't want to sit here and say, it's 100% the fault of the person, but it's hard to get around the individual responsibility component. And I think that makes it uncomfortable for some people to discuss.
Yeah, no, I agree. I've done a lot of weight loss studies, and sort of your point, everybody doesn't have the same energy balance. Calories aren't exactly the same in every individual. And so one person may lose, put that person on a 500 calorie deficit and they'll lose, 10 pounds in the next 3 weeks. And you put another person on that same deficit and they might gain pounds. It's sort of like everybody's isn't the same, but everybody does have an energy balance. It ultimately comes down to an energy balance. And as you go through life, every one of us changes. My energy balance now is vastly different than when I was 25. I was participating in sports and physically active. And, now I'm 75 and, my calorie needs per day is probably 1,700, even working out an hour and a half a day. It just, I have to have that nutrient density and far fewer calories. So my energy balance is vastly different than it was 50 years ago.
Well, and I think my little add-on I would go in there, because I can be very pedantic, would be when we say a 500 calorie deficit, we'd say a predicted 500 calorie deficit, right? Because if it actually was, we would see that loss. And I think that's one of the things I try to get to point out to people is a lot of people look at calories in, calories out as independent variables. And the reality is no, these are dependent variables, because if you change the calories in, you change the calories out. And there's some evidence that if you change the calories out, you also change the calories in. And so these things are moving targets and adjust. And I'm even thinking about a paper from Levine in 1995 that was very classic. They overfed men, it might have been men and women, by 1,000 calorie targeted surplus per day in a metabolic ward. And I think it was over an 8-week period. And they found that the average weight gain, I think, was around like 5 to 6 kilos in that time period. But the spread was from 0.8 kilos to almost 9 kilos. And what they found was, in one aspect, that people who were more obese prone tended to not compensate for increased energy intake by increasing their spontaneous activity, whereas people who were obese resistant, if they overconsumed calories, they spontaneously increased their activity. And I have to be very clear about that. They were not instructed to, and they did not do so on purpose. It just happened. And so these are inherent characteristics that change the equation of energy balance and may make it easier for some people versus others.
Yeah. Yeah. Your point, initially sort of following up what I said, a 500 calorie deficit, when we put a number on it, it's an addition or a deficit from wherever we thought they were at. And so, a 500 calorie deficit to somebody who's overeating by 2,500 per day is not the same as a calorie deficit of 500 to somebody who's actually at their target. And so, we tend to use it as an absolute 1,000 calorie addition or 500 calorie deficit, but there's not the same starting points.
Exactly. And one of the things I'll tell people all the time is, they'll say, well, I ate in a calorie deficit and didn't lose weight. And I'll say, okay, well, how did you figure this out? And it's, it's some online calculator or whatever. And I say, well, what do you think is more likely? That you're somehow defying the laws of thermodynamics, or that maybe that calculator might have been a bit off with you, or maybe you're making some tracking errors? I'm probably going to bet the latter versus the former,
Yeah. No, I think, coming up, and it's one of the reasons when we did our weight loss studies, we tried to avoid the numbers. We tried to generate a concept of portion size for people, and we targeted what we thought was a deficit. But if they weren't getting a weight change, then we started to adjust the portions. So we were never really trying to count the calories, because the math never works out. It's never clean. You never know really what's going in. Those numbers aren't accurate. And you never know what's going out. Those numbers aren't accurate. So you really just have to kind of get an understanding person to person about the portion sizes you're trying to get to.
Yeah. And when it comes to tracking, people will make that point, that labels can be off. There can be tracking inaccuracies. And what I'll say is that's true. But if you have been tracking for a while and you're consistent with the way you track, even if, let's say, you're eating 200 calories more than you think you are, if you're not making progress, if your goal is weight loss, well then, okay, maybe you think your calorie intake is 2,000 when it's 2,200. Well, what you do know is if you're stagnated, you're going to have to drop either way. So if you continue to track the same way, you can make progress.
Yeah.
But it's, this idea that we can exactly nail the calories. No, these are, I think about these like electron clouds, right? Like you can't ever know exactly where it's going to be. You can only predict a probability. So I do have one more question. I'm going to circle back to protein distribution. When I did my PhD, every time I wrote up like my prelim and then writing up part of my thesis, you actually brought to me, you said, you talk a lot about distribution in this thesis, and there's no studies actually looking at distribution. So you probably should measure that unless you want to take that portion out. So we did do a study on distribution. I won't spoil it. I'll let you talk about it. But how much do you think protein distribution matters? This is something I have adjusted my thoughts on in terms of how important I think it is, but I'm interested to see where you're coming from and how close we are in this. How much does distribution matter?
I guess I'd answer it in two different ways, but let's start first with age. I think in individuals under 30, it makes almost zero difference. I think it's protein per day. The system is mostly driven by hormones, and I don't see much evidence that it matters much. I think that there's enough evidence to say that, if you're a 20-year-old and you eat 10 grams of protein, you will get a metabolic response. If you eat 20 grams, you'll get maybe twice as much, but it's almost a linear response up to some break point where it kind of begins to flatten out. Once you get beyond 30, 35, now we get into that anabolic resistance where hormones aren't driving it anymore. And now we need to look for strategies to maximize the effect. And the question I would always ask people, if time of the day doesn't matter, why does everybody always run the studies after an overnight fast? And the answer to that either is that they're all lazy and they don't want to get up and do the study at 4 p.m, or what we know from every animal study that's ever been done, that's the most sensitive time of the day. And that if you're looking at what does mTOR and leucine do, well, they're recoveries from a catabolic state. And what's the most catabolic state that the human encounters under normal conditions? Well, it's the 12-hour overnight fast. And so that meal is the most sensitive meal. And so, when we did all of our weight loss studies, what we did was shift the protein to that first meal. And so people say, well, unfortunately, Doug Patton-Jones and I ran a study where we basically took 90 grams and looked at it in an uneven distribution versus an even distribution. And what we saw was increased protein synthesis for the 24-hour period. I think that's true, but does that actually translate into a body composition change within any reasonable short period of time? Maybe not. If it actually is going to affect sarcopenia, for example, how long would you have to measure to pick that up? 2 decades, 20 years? So obviously that's not going to be easy. What we did was ask the question a different way. So what we did was basically take people on a low protein diet. They were eating the RDA, 0.8 grams per kg. And we were looking at weight loss studies. So now we've got them in a catabolic state. So we're basically accelerating sarcopenia in a short period of time. They're catabolic. They're losing muscle mass. And so then what we looked at is doing twice that amount of protein, 1.6 grams per kg. And so the question is, where do you put that extra 50 grams of protein? If they're eating a 10, 20, 50, whatever that number is, 50, 30, that's 90, I guess. If they're eating at a 10, 20, 50, where do you put the extra 50? Do you put it on top of the 50, or do you put it on top of the 10?
And what you're referring to is breakfast, lunch, and dinner, because
breakfast, lunch, and dinner.
De Castro showed
exactly.
that I think it's over 65% of total protein intake for Americans is at dinner, correct?
Exactly. So you're getting like 60 grams or so at dinner. And so as we talked about earlier, protein synthesis is a curve of diminishing returns. It goes up to some point and 30 grams or so, and then it begins to plateau out. So 40 is probably higher, 50 is probably higher, but now you're getting into marginal change. So if you've got a meal that's already got 60 in it, where should you put the next 50? I think it's obvious that the distribution is breakfast. There's a paper, And you can also look at things like vegans, vegetarians. There's a paper by Arnold that I know you remember, and they were using, I think, 68-year women. They were eating about 50 grams, 55 grams per day, and they looked at whether it should be in 4 small meals, all around 15 grams, or should it be in a large meal that had almost 50 grams in it. And they showed within 2 weeks a change in body composition, nitrogen balance by just centering it on one meal. So I think the issue is you want to maximize your ability to get out of a catabolic condition. And if you're under stress, I think that first meal after an overnight fast is important. Average American, healthy, not under metabolic stress, are they going to see a big difference in meal distribution? Probably not in any meaningful time. But I think that particularly in sedentary individuals, people under any kind of stress, people aging, I think that first meal is really important to get out of that catabolic period.
Yeah, and the Arnold paper you're referring to, we interpreted that paper very differently than most other people in the nutrition space, which some of the interpretations were, oh, we should be having most of our protein at one meal. And our interpretation was, well, you had either one meal that got a response or you had 4 meals that got no response. So yeah, if you've got to pick between, if you're only going to eat 50 grams in a day, yeah, you're better off having one meal really high in protein versus 3 or 4 meals that are low in protein.
And we did that. I mean, you basically did that study. Right. So we basically figured out, so what's the leucine threshold that would go with that Arnold study? And we realized that it's somewhere around 35 grams of protein in a human. In rats, we recognized that it was around 55 milligrams at a meal. And so we designed a study with adult rats that basically we had one set of rats that were getting above the threshold at all 3 meals and another set that were getting above the threshold on only one. Everything else about it, 100% the same in calories. So we knew we controlled energy balance. We knew we controlled total protein per day. We had total control of it. We got to the end, and what was interesting is that using DEXA, we couldn't see a difference in the body composition between the animals. But when we dissected the animals and actually weighed the organs and the muscle, what we found was the animals that had a better distribution had larger muscle size, where the animals that had all their protein grouped in one meal had larger organ size. And so that's the deception of organ. And, you know, how long do you have to do it? How long would it have to be controlled? And how do you measure the outcomes? That's why people won't pick it up in 4-week studies with humans. They're not going to see a difference with DEXA. That's
absolutely right. And just to really highlight this study, I remember doing this study and you going, well, I don't think anybody's going to replicate this anytime soon. There was over 100 rats in this study. I don't want to say myself, Gabe Wilson, created all the diets. So we mixed these by hand. They did not come from a store or a production company. We mixed these by hand. We weighed over 300 meals per day for each rat. Now, some people will...
He's still speaking to me, everybody. He's still speaking with me.
Yeah, there were a lot of early days in the lab. And we fed them at very defined times. Now, I will often point out, listen, you guys are talking about this animal study. We have human data on this. Here's what the human data shows. A lot of times it is about, is it the right model for the human thing that you want to measure? Rats, for certain things, I'm thinking longevity research, a rat is a relatively poor model for longevity because rats grow throughout the entire course of their lifetime. Primates are different. But for protein metabolism, for muscle protein metabolism specifically, the rodent is actually a very good model. And studies are always limited. So when people ask me, well, why didn't they have more subject number? Well, why didn't they control it more? Well, why didn't they do it for longer? And the answer to your question is money, money, and money. Because I think people think that research subjects just sit in this pool twiddling their thumbs, waiting for researchers to say, okay, now we need you. And they go, oh, great, I wasn't doing anything else. And the reality is that research subjects are people like me, people like you, who have jobs, who have lives. And the more control you try to exert over their life for a longer period of time, the more difficult it is to recruit. And quite frankly, at some point, you have to pay them a decent amount of money to be able to do it. And not only are you paying them money, you're paying for the actual analysis of your study. So if you want, I always tell people, if you want high control, high subject number, and long duration, your only option is in animals. That is it. Yeah. That is your only option. Yeah. And so we did this study for 11 weeks. And the other thing to point out, 11 weeks out of a rodent's life, which lives for about 2 years, is a very long period of time. And in that time period, the difference in hind limb weights that we got, I think in the gastrocnemius muscles, was like 5 to 10% difference between the groups. So I walked away from that going, you know, this is really, really tightly controlled. And actually, I thought we were going to see bigger differences, right? But I walked away going, okay, I think distribution's important, but I think we can safely say that total protein per day is the most important. And then under that, distribution falls somewhere. And I think your feeling is in line with that. Yeah. I totally agree. I think it's a total protein per day. And then you start thinking about distribution. I do think that first meal is important, and sort of translating the animal data. I think of that data, sort of an 8% difference in that period of time is sort of equivalent to probably about a decade. So it's probably sort of in the realm of a decade relative to sarcopenia. And so, how can you control a human diet and activity and everything for 10 years or more? But does it matter? I think I've seen enough data to make me think it matters enough that people should practice that. I think protein at that first meal is a worthwhile endeavor. I think in terms of, does cholesterol matter? Does saturated fat matter? Does salt matter? I think we know that first meal for protein matters as much as any of those things. Right. I think your point too, just from a practical perspective, if you were going to put more protein in, where are you going to put it? Where you've already got high protein, or are you going to put it in a place where you don't have high protein? And I think the obvious answer is at breakfast after a catabolic condition.
Yeah, I think that's the take home. I see people walking out of the gym downing protein shakes and things, and I just don't see much value to that. If it's part of their protein per day, that's one way to get it in. Okay, fine. I think there's enough evidence that overnight fast is catabolic, that I think there's merit of getting out of that catabolic condition.
Yeah, and I completely agree with you. And this is as somebody who sells whey protein powder, right? Hey, I would never going to tell you need whey protein, but it is a relatively inexpensive, high quality protein that's pretty easy to make taste good. And if it helps you reach your total protein intake, especially for elderly people who have trouble with mastication, I think it's a very good supplement to have. But you don't need it if you get it from whole food.
I mean, we found that all of our studies that getting people to consume 30 to 40 grams of protein at that first meal was always a challenge, especially with older people. So, I sell a protein shake too. And, we developed it for those studies because how do you consistently get in 35 to 40 grams of high quality protein at that first meal? That's a lot of eggs. Most people can't do that consistently. So, I'm a fan, and I think for people who are trying to get more protein, particularly elderly, even for me, I like the convenience of it. If you're busy, you can throw together a shake and drink it on the way to work or whatever, as opposed to cooking in the morning. So I think there's merit to these kinds of protein shakes as a way to get that first meal up in protein.
Are you looking to level up as a coach? I mean, really take things to the next level? My Physique Coaching Academy is what happens when you take college level research-based education and make it actually usable for coaches. Dr. Bill Campbell and I teamed up with our partners at Clean Health to bring you the most comprehensive, research-based, college-level education on how to coach muscle building, fat loss, and optimizing metabolism, and how to apply it practically to clients. This isn't bro science or surface level or influencer fluff. This is real science-based coaching that will separate you from the noise. If you're tired of guessing and you want to coach with confidence, check out the link in the show notes to enroll in Physique Coaching Academy. This is what the industry should have been offering all along, and I'm excited to share it with you. Let me be your professor. Okay, so now some quicker rapid fire questions to end.
Okay. Enough of these long lectures that I'm giving.
Hey, you and I could keep rapping for another 2 hours. So
absolutely,
unfortunately, nobody else is gonna nerd out with us down that rabbit hole. What do you think your biggest contribution to the field of nutrition has been, if you had to pick one thing?
I would probably say we've had a big contribution to what Dr. Gabrielle Lyon and I like to call muscle-centric health. I think we've sort of made people think more about muscle as an organ of metabolism. And I think that our discovery of really the leucine role in muscle protein synthesis, is what most people would give us credit for. So I think we've brought a new understanding to protein quality and particularly an understanding to the role of leucine and mTOR in muscle health.
I'll just add parenthetically that you were a fantastic graduate advisor, and the longer I've been out of it, the more I've realized, talking to other former graduate students, that my experience was not necessarily the typical experience. And so usually in other settings, I often make that statement that I think my major contribution was that I trained 40 graduate students that went out and made a difference. So that's probably my real contribution. Well, and you said that as much at the dinner we had for your long overdue award from the American Society for Nutrition. That we all the grad students at the table felt the same way, that we were just blessed to have you as an advisor. On that note, what piece of advice would you give young scientists, if you could give them one piece of advice?
I think to become a research scientist, you have to have a passion about it. I always remember one of my early chemistry courses. I was in an inorganic chemistry course, and the professor said, when you find what you're supposed to do in life, it'll be easy, and this isn't it. And so I knew I needed to keep looking, and I finally found that biochemistry was good. I understood it. I had a real intuitive sense. I sort of have a three-dimensional picture that swirls around in my mind about metabolism. And, I think that you have to have a passion, and you really need to have some intuition about it. You kind of always need to see the light at the end of the tunnel. And you need to be excited about that, because as you point out, 3 out of 4 or 9 out of 10 experiments fail. And so you have to learn from those. There's no such thing as bad data. There's really just data you don't understand. And so how do you learn from that? How are you excited day to day to go back when the last thing failed and, you move on? So I think it's that passion and that sense of discovery that you wake up in the morning and you might go discover something. I think just has to be there.
That's a great point. And I'll share with the audience something you said to me that was very impactful for me. We had an experiment, and I don't want to go too much into the weeds of it, but the data did not make sense to me based on my preconceived notion of what the outcome should be. And I kept rerunning the plasma amino acids over and over. And finally you asked me where we were with this study. And I said, it's almost done. I just got to run the data one more time. And you said, well, you've been running this for months now. What's going on? And I said, well, it just doesn't, it can't be right. And we went through my technique. You said your standard error bars look good. There doesn't seem to be a lot of noise in the data. It seems like you are trying to get the data to fit your conclusion. And what you need to do is change the conclusion to fit your data. And I think that was one of the things that I was so grateful for was there was no being wrong in the lab. I mean, you could have a hypothesis that ended up not being supported, but you didn't tend to take that super personal. It was just, okay, the data is what it is. Now, how do we explain it? And then you get into the fun part of going further down that rabbit hole, which I actually think that duration study was actually the most interesting stuff that my PhD produced. And here I was.
I think it's an incredible study, and it was hard to do. I think it's incredible. And I think that people ask about bias in nutrition, and I think, we all eat, so we're all inherently biased. We all start with a bias. And anybody who says that's not true is just lying. And so then the question is, are you enough of a scientist you're not wedded to your conclusion? Can you change? I always remember David Krzyzewski, which is a person of my era, that said, if you torture the data long enough, it'll confess. If you're just going to run the experiment till you get the outlier to fit your conclusion, you can eventually find it.
Yeah.
But if you run it and you get the data that's different, then you have to adjust. And I think that's a true sign of a scientist who can understand the data and what it's actually telling you. And frankly, that's kind of rare. There are most people who basically are wedded to their hypothesis and won't change.
Yeah, I think, I don't know if you said it, but I heard, date your hypothesis, but don't marry it because the divorce is a what.
Sort of along that line, I think Max Planck was the person who said that science only advances one funeral at a time. Basically, there are too many people wedded to their hypothesis to make science advance.
Yep. And if you look at a lot of scientific advances, there was a lot of pushback. Even the concept of DNA, ATP as an energy substrate, all that stuff had considerable pushback.
The flat Earth.
Yeah, absolutely. So on that note, what is one belief that you used to hold that you adjusted or changed with evidence?
I'd like to just say I was always right. No. I would say that I went to graduate school basically accepting all of the nonsense about cholesterol and saturated fat, that I basically accepted all that diet heart disease stuff and said, obviously cholesterol is going to kill you, and saturated fat's unhealthy, and seed oils are fine, trans fats don't matter. And basically all of that's been proven to be wrong. And so I've had to slowly adjust from what I was at in Minnesota, which was sort of the seed of all of this, with Ansel Keys and Ivan France and the Minnesota Heart Study, and basically try and find a perspective for that. And, I have evolved in how I think about that. And I think that we still don't have enough nuance in how we treat things like saturated fat. We know that dietary cholesterol is irrelevant now. Only took 30 years of research to prove it. We know that trans fats are probably one of the worst things you could ever encounter.
Yes.
I was at Minnesota when Fred Kummerow gave that lecture, and everybody in the world of Ivan France and those guys laughed at him, and he turned out to be totally right. And so all of that saturated fat and hydrogenated fat and trans fat we know is unhealthy. And so, I've evolved at how I think about all of those fat hypotheses, and I think they're totally overstated, and we still need a course correction on how we talk about them.
Interesting, because we're going to run out of time to talk about this, but we'll have to come back on specifically to talk about this, because I think I've actually gone the opposite direction a little bit. Whereas I came into graduate school thinking, I don't think LDL cholesterol matters. I don't think this stuff really matters. And now I've kind of come a little bit further back to, I think it's one piece of the puzzle. I do think it matters, but again, the problem is you're having an intersection of multiple different things. People think about nutrition a lot as nutrients, but we don't eat nutrients, we eat foods. And when you are eating more of something, by default, you're eating less of something else. And so, one of the things that is a trade-off, for example, is, okay, if you're eating a diet that perhaps lowers your LDL cholesterol, but it raises your triglycerides, or it lowers your HDL, or decreases your insulin sensitivity, how does that intersect? Now, I think what I would say is, okay, all things being equal, right? Low inflammatory status, low triglycerides. If you have lower LDL, I'd say that's better off than having higher LDL. But the problem is trying to figure out how these variables all intersect. And that's where nutrition gets really, really messy because, as you pointed out, you can't do a 10-year randomized control trial. We have to rely on cohort data, which is notoriously messy.
Yeah. And I think the way you said it is frankly the exact way I object to it. The issue is higher and lower. So what level of LDL can you absolutely tell me is going to kill me? Is it 160? Right now, what we have is the belief, based totally on statin research, that the lower the better in people at risk. And so the question is, who's at risk? I have an LDL of 125, and yet the dietary guidelines say the most dangerous thing in my diet is the saturated fat. What evidence can you give me to say that reducing my saturated fat by 15 grams per day is going to allow me to live 20 years longer? Give me a piece of data that you can back that up with.
Right.
So what percentage of people are actually at risk? So I think the risk is pretty clear if you're above 160. What percentage of the people are actually above 160? Well, it's less than 11%. So is it right that we have our entire dietary guidelines built around the negative nutrient of saturated fat as a public health recommendation when in fact it affects an incredibly small minority of people? So we have distorted the entire American diet based on some nonsense about saturated fat that applies to less than 15% of the population. That's my problem.
Right. And I think, if I play devil's advocate, it would be, these Mendelian randomization studies that are longer term, and then the cohort data. But again, all that stuff can be very messy. And a lot of this is attempted regression analysis, which is useful, but you're not necessarily directly measuring something. You're trying to project.
And those regression analysis are based on statin data. And statins do far more than affect LDL.
Correct.
What they want you to think is it's an LDL effect, but statins are have more impact than that. And so that's the basis, along with some genetic studies of people who genetically have low LDLs. Those are the only two pieces of data. And yet, as you point out, we know that lowering total calories, we know that lowering carbohydrates, we know that changing insulin, all of those will also affect it. So that saturated fat seems to have almost no effect in carnivores or keto people or whatever. I mean, if it really was important, they should all be dead by now.
Well, I think, we would have an interesting discussion to go over this because I think we would disagree in some areas. But what I appreciate is that we both can say, hey, we changed our mind on this and we have different perspectives, but that is what creates good scientific discussion and generates more ideas. And I guess if I had to end on one note, I would say, hey, for those of you out there, it doesn't have to be like an us versus them as scientists. this should be like figuring out problems. Unfortunately, because of the way grant funding works and all these sorts of things, it can kind of turn into that. But, these are all pieces to a puzzle. And if we could just not get too married to our own beliefs, that would produce much more curiosity and better overall data quality than if we just spent too much time trying to confirm the things that we already thought were true.
Yeah. And, scientists who stake their career on proving that saturated fats are the worst thing in the American diet, the likelihood of those changing that opinion based on whatever they find is very low. Yep. And so the issue is, how do we moderate that in looking at nutrition? And so, I think there's plenty of evidence that humans get along pretty well on a wide variety of diets. And what you then need to do is look at the individual and say, well, that person seems to have a genetic issue with LDL, or that person has a problem with triglycerides or insulin sensitivity. And then you respond to the diet. My problem is that we have a one size fits all, that I know more than you, and therefore I have dietary guidelines that everybody should follow, whether it's school lunch or nursing homes or daycare centers. And I think that's a lie. I think nutrition is not that sophisticated, and we need to have a much more flexible approach to how we construct good diets.
Absolutely. And I think, that will hopefully be some of the next generation of nutrition research, is more of this personalization to it. So you are retired, you're professor emeritus. You mentioned you have a protein powder, protein shake. Where can people find that? If you're not really on Instagram, I know you're on Twitter. Where can they find you, learn more?
All right, so on Twitter, we basically developed a website called metabolictransformation.com, which is our website. People always ask for how did we do our weight loss studies? So we published the studies, but we never really published the diet. So we created a website where people can go get it. We also sell the shakes there, so people can get it. It's not really a business. We really created it for people who asked to have access to it, so it's there. So anyway, I'm somewhat visible, but not very. Twitter's about my only access, and anyway, people can follow the comments that way to some extent, and I rely on people like you and Dr. Gabrielle Lyon to keep me visible.
Absolutely. And just to be clear, he did not teach me my bedside manner. I picked that up from my parents. So he's a much more professional follow than myself, but I did get, honestly, I felt like I got such a great education, and not even the coursework at Illinois was great, but really what made the difference for me was being around you, Peter Garlick, being around the graduate students there. Really, I can absolutely say I would not be where I am today if it was not for that experience. So I cannot thank you enough, and I appreciate you being the first guest on my podcast.
I appreciate that, and thanks for inviting me. And I love the interaction with students. I love sort of being a mentor, father figure in that point of people's lives. And that was really one of the truly rewarding parts of my career. So I appreciate that.
Absolutely. And it's so funny. I never thought of myself as a smart person until we were at a scientific conference and you said, Lane just has this uncanny ability to draw on studies like nobody I've ever seen. I go, what? Yeah. Because you're like the smartest person I ever met. And I'm like, oh, wow, I have a talent? I didn't know that. I just thought I slugged my way through graduate school, So thanks for making me feel good about that, because I felt like I was stumbling my way through.
No, you still have a much better recall of all kinds of studies than I do. And I'm pretty good at it, but you're vastly better.
It does not translate across things. I wish it did. Well, Don, and again, it's still weird for me to call you that. Don, thank you for joining us. Really enjoyed it. And if it's okay with you, I would love to have you on again, and we can dig more into the saturated fat conversation, because I think it'd be really cool.
Sounds great. I'd love to chat about macronutrients with you anytime.
Absolutely. Thanks, Don.
Thank you.